Balloon 9.2 Aeromedical factors. Let's delve into the critical aspects of dehydration. This occurs when there is a significant loss of water from the body, leading to the first noticeable effect, fatigue. As pilots, flying for extended periods in hot weather or at high altitudes makes us more susceptible to dehydration. The dry air at altitude tends to accelerate water loss from the body. Without proper fluid replacement, fatigue can progress to more severe symptoms, including dizziness, weakness, nausea, tingling of hands and feet, abdominal cramps, and extreme thirst. So, it's crucial for pilots to carry an ample supply of water, ensuring proper hydration during long flights, regardless of whether they feel thirsty. Moving on to heatstroke, this condition arises from the body's inability to control its temperature. Symptoms of dehydration may precede heatstroke, but it can also manifest suddenly, leading to a complete collapse. To prevent these symptoms, it's advisable for pilots to carry an adequate supply of water and drink at regular intervals during extended flights. Now we can see a visual representation emphasizing the importance of hydration both before and after participating in outdoor activities. This figure illustrates that while dehydration is an obvious concern during hot weather, individuals can dehydrate during cold weather as well. Now, let's shift our focus to the impact of alcohol on pilot performance. Consuming alcohol significantly impairs the efficiency of the human body, and studies have confirmed a direct link between drinking and performance deterioration. Pilots are required to make numerous critical decisions during a flight, and the influence of alcohol drastically reduces the chances of completing a flight without incident. Even small amounts of alcohol can impair judgment, decrease the sense of responsibility, affect coordination, constrict the visual field, diminish memory, reduce reasoning power, and lower attention span. Notably, alcohol consumption has more pronounced effects at altitude, with the combination amplifying the impact on the brain. Intoxication levels are regulated by 14 CFR Part 91, Section 91.17, which requires a blood alcohol level of less than 0.04% and a minimum of 8 hours between drinking alcohol and piloting an aircraft. We have a visual representation highlighting the reduction of atmospheric pressure that accompanies flying, potentially causing physical problems for scuba divers. Underscores the importance of understanding the interaction between scuba diving and flying to minimize the risk of adverse effects related to changes in pressure. As we delve into the crucial aspect of vision in flight, it becomes apparent that among all the senses, vision reigns supreme for ensuring safe aerial endeavors. Flying is inherently a visual activity, with most information gathered and processed through the eyes. Yet, vision has its limitations, characterized by phenomena like illusions and blind spots. To navigate these challenges effectively, a pilot's understanding of ocular mechanics and potential pitfalls is paramount. Consider the eye as a sophisticated camera with an intricate structure comprising an aperture, lens, focusing mechanism, and a surface for registering images. Light enters through the cornea, travels through the lens, and lands on the retina, where light-sensitive cells, rods and cones, convert it into electrical impulses for interpretation by the brain. Cones, responsible for color vision, are concentrated in the fovea, the center of the visual field, while rods, crucial for low light and peripheral vision, dominate the outer areas. Yet, even this remarkable visual system has its quirks. The optic nerve's entry point creates a blind spot in the visual field, a gap typically compensated by each eye's blind spot. Empty field myopia, induced nearsightedness in the absence of focal points, poses another challenge, particularly during night flights or in reduced visibility. When transitioning to night vision, the rods, which are exceptionally sensitive to low light, take center stage. They surpass cones in sensitivity by a staggering 10,000 times, making them the primary receptors in darkness. However, the fovea's cone concentration can create a night blind spot in the central visual field. To mitigate this, pilots must focus slightly off-center to engage the rods effectively. In the context of balloon piloting, though nocturnal operations are rare, low light conditions or haze during the day can mimic challenges associated with night flights. An intriguing note relates to the impact of burner light on night vision. During night glows or tethered operations, exposure to the burner's light can temporarily impair vision, requiring recovery time. Understanding these intricacies is crucial for pilots, as night vision, once compromised, takes time to readjust. Factors like diet, physical health, and external influences such as carbon monoxide, smoking, alcohol, certain drugs, and oxygen levels can significantly affect night vision. In closing, Balloon pilots, unique in their self-certification for fitness, must exercise this responsibility judiciously. Major medical issues necessitate careful consideration, and adherence to FAA regulations, particularly those outlined in 14 CFR Part 61, is paramount. Seeking guidance from an aviation medical examiner, AIM, ensures a holistic approach to physical well-being in the realm of balloon piloting.